In this video, we're going to be looking at the tangent function. For more videos in this unit on trigonometry, visit parkermaths.com/Y1 So we've previously seen how we can define sine and cosine in terms of a point on the unit circle. We've said cosine theta is the x coordinate of the point and sine theta is the y coordinate of the point. Let's now have a look at how we can define tan theta in terms of the unit circle. Suppose we take the radius and we extend it slightly, so that we can then draw a tangent to the circle which meets with the radius. The length of that tangent is what we define to be tan theta. Now it is possible to calculate tan theta using the unit circle, because here we have a right angled triangle where the base is the radius, the height is tan theta, and the length of line from the origin to the extended radius meeting the tangent is called secant of theta. But that's a quantity we don't actually meet until the second year of the course. So we're going to look at a different way that we'll use to calculate tan theta in the first year of the course. We'll start with tan theta written as a trigonometric ratio. Tan theta is opposite over adjacent. And then we're going to divide the top and the bottom of the fraction by the length of the hypotenuse. That gives us opposite over hypotenuse divided by adjacent over hypotenuse. We can do that because it simply gives us an equivalent fraction. And if you look at what we have on the top and the bottom of this fraction, you might recognise that they are other trigonometric ratios. Opposite over hypotenuse is sine, adjacent over hypotenuse is cos. And so we get tan theta equals sine theta over cos theta. And because that is true for all values of theta, we can say that tan theta is identical to sine theta over cos theta. And this is an identity that we will use frequently throughout the course. And it's really important that you try and memorise this one as soon as you can. Let's have a look at how we might use this identity then to evaluate the tan of 150 degrees without a calculator. In a previous example, we drew a unit circle diagram to find sine and cos of 150. That's what you can see on the screen here. And we found that sine 150 was a half and cos 150 degrees was negative root 3 over 2. So to find tan of 150 degrees, we can use our identity, tan theta is sine theta over cos theta, to get sine theta on the numerator, which is a half, and cos theta on the denominator, negative root 3 over 2. To simplify this fraction, we can consider dividing by negative root 3 over 2 to be equivalent to multiplying by the reciprocal. So we end up with 1/2 multiplied by negative 2 over root 3. Then we can multiply the numerators, multiply the denominators, and we get negative 1 over root 3. So in situations where we know the value of sine theta and cos theta, we can quickly work out the value of tan theta.